Hi guys, and welcome to our last new video for this chapter. Today, we're going to focus on the second part of the title. We've already done exponential equations a couple times, actually. So today, we're really going to focus on logarithmic equations. Now, we've done some problems in the past where we've had to solve for x when it was after the equal sign. And last chapter, we actually did some where we had to solve for x when it was below the log, when it was the base. And we can review those a little bit more in class. But today, I really want to focus on what to do when x is contained within the log, when it's part of the input. So we're going to focus on problems where we are taking the log of x. All right, so when we were doing exponential equations, we looked at them and we said, you know what, I need to change this into log form. Well, when we're doing log equations, we're going to do the opposite. We're going to look at this and say, you know what, I should probably change this into exponential form. So if you start a problem with the word log in it, then you want to change it to exponential form. You want to get rid of the word log. To do that, we need to know what the base is on this log. And so we learned last week that if there's no base, it's the number 10. So I'm going to put a 10 underneath my log, and then I'm going to do the wheel. So this one is 10 to the power of -1 equals 3 minus 2x. 10 to the power of -1 equals 3 minus 2x. The very next step after doing the wheel is always going to be to figure out what this thing turns into, right? So we've got 10 to a power. We should probably change that to like a regular normal number. And so that's the next thing we're going to do. And again, that's always going to be your next step immediately after doing the wheel is like evaluate the exponent. So 10 to the -1 means 1 over 10, or 0.1 would also be acceptable. And now we solve for x, and we've done that before. Now, if you're using fractions, maybe you don't like the fractions, and so we can get rid of the fraction by multiplying everything by 10. It does literally have to be everything. The fraction itself, the tens are just going to cancel, and then it's not going to be a fraction anymore. We're not going to like multiply because the 10 is going to cancel, but you should multiply the 3 and the 2. And that just makes the numbers a little bit easier to work with. So that's a way to get rid of fractions if you don't want to deal with fractions. Again, your other option was to change it to a decimal. Make sure, though, if you're doing tonight's homework on your Delta Math, if Delta Math says, hey, write it as a fraction, then you have to be able to write it as a fraction, and you should not be writing it as a decimal. And Delta Math won't give you credit if it says to write it as a fraction and you write it as a decimal. It's going to say it's wrong because you didn't read the directions. So read the directions carefully. The answer to this problem is 29 over 20. Okay, now on this problem, everything next to the word log was completely contained within some parentheses. That was grouping it all together and saying all of this stuff belongs to the word log. I am taking the log of 3 minus 2x, all of it together. But that's not always the case. So let's take a look at the next problem. In this problem, there are no parentheses surrounding my adding problem. That means that the plus 3 is not connected to the log. In this problem, I am only taking the log of x. And then there's a plus 3 after it. So because the plus 3 is not in parentheses, it's not attached to the log, and I need to move it to the other side before I can do the wheel. So you do need to pay attention to the way that it's written. You want to be on the lookout for parentheses versus no parentheses. And we do need to get the log alone before we can wheel it out and make it an exponent instead. So I'm going to start by minusing the 3 to the other side. And so now my log with its x, right, because we're taking the log of x, is all by itself. So now I can do the wheel. So put a little 10 underneath it. It's 10 to the -1 equals x. We just talked about this on the last slide. 10 to the -1 is 1 over 10. And guys, we're done. The x is all by itself. That's it. Okay, so just be on the lookout for numbers that are not attached to the log and make sure to move those first. I want to show you a problem where a number is being multiplied and not attached to the log. So I'm not taking the log of a multiplication problem. All right, so in this problem where the 2 is in front of the log, obviously I'm not taking the log of 2 because it's in front of it. It would have to be after it. So if I want a multiplication problem to not be part of the log, if I want a multiplication problem to be moved to the other side, I'm going to put the multiplication part in front of the word log. Now, just to clarify, because there's not going to be parentheses around a multiplication problem. If this was the log of 2x equals 6, then I'm taking the log of the 2x. And that 2 is part of the log, and I would not move the 2 to the other side. So multiplication problems will not have parentheses around them. And so you can put parentheses around it if that helps. So if you see 2 times x, that is connected together, and that is all part of the log. And you would start the red problem by doing the wheel. The one that's actually typed on the screen where the 2 is in front of the log, for that problem, you would start it by dividing by 2 on both sides. Okay, so a 2 in front of the log, you divide. A 2 right next to the variable, you start with the wheel. And then hopefully maybe we're getting good at this. Okay, so my final answer for this one is x equals 1,000. Okay. We'll practice this a little bit more in our live section, practicing like what's connected, what's not connected, what do I need to move, what can stay, and things like that. So we'll talk about that a little bit more in our live session.